Welcome to Chapter 19, Section 19.1, Calculations for Compounding. So, liquid medications include solutions, emulsions, lotions, and tinctures. Liquid measures are made up of two main parts. So the first main part they are made of is the liquid used to dissolve the other ingredients. Alright, and the second part that they are made up of is the dissolved materials. Oop, almost misspelled that one. Alright, the dissolved materials. Okay, so Rule 19.1, for liquid mixtures containing a solid medication, the percent strength represents the number of grams of medication contained in 100 milliliters of the tincture. So, for the first example, we might have 2% hydrocortisone, a 2% hydrocortisone lotion contains 2 grams of hydrocortisone in every 100 milliliters of the lotion. Okay, so that's an example. For a 2%, that is saying that there are 2 grams per every 100 milliliters. Alright, Rule 19.2. For liquid mixtures containing a liquid medication, the percent strength represents the number of milliliters of a medication contained in 100 milliliters of the mixture. For example, if we had a 50% ethyl alcohol solution, oops, misspelled that. This contains 50 milliliters of ethyl alcohol in every 100 milliliters of the solution. Alright, so for liquid, that is the milliliters per every 100 milliliter in the solution. For Rule 19.3, when preparing a liquid compound, first measure the medication, then add the sufficient quantity of solvent to bring the final volume to the desired level. Alright, so let's write a recipe for preparing 100 milliliters of 2% lidocaine solution from lidocaine powder and water. So we want 100 milliliters of a 2% lidocaine solution from lidocaine and water. Okay, so to prepare this, we need 2 grams of lidocaine powder and enough water to bring the final volume to 100 milliliters. Up to 100 milliliters. Okay, so a recipe might look like the following. For a 2% lidocaine solution, for the lidocaine, we would have 2 grams, and for the water, we would have, here we go, I'll show what this means in a second, QSAD 100 milliliters. Where QSAD means, or it's taken from the Latin, which means a sufficient quantity to adjust the dimensions. So when we're preparing a liquid solution, we need to make sure that the solution and the diluent will add up to the desired volume. Okay, so for next one, procedure checklist. So we're moving on to procedure checklist called 19.1. This is when we're calculating quantities for percent strength liquid compound using the proportion method. Okay, so while we're doing this, we're going to refer to the rules we just went over. Writing a fraction from the percent strength desired with the amount of medication in the numerator and 100 milliliters in the denominator. Okay, then we're going to go ahead and convert the volume ordered to milliliters. Then write a fraction with the unknown x in the numerator and the total volume. We have done this before when we're solving proportions. And then step 4, cancel any units, and finally solve for our unknown value. Okay, so let's read our problem. Calculate the amount of sodium iodine powder needed to prepare 1 fluid ounce of a 5% sodium iodine solution. Alright, so first we're going to go ahead and use rule 19.1 and write our fraction as 5 grams of sodium iodine powder. Okay, so we're using rule 19.1 because this is a powder or a solid medication. It's not a liquid medication. We'd use rule 19.2 if it was liquid. So since it's solid, we're going to go ahead and use rule 19.1. Put the grams over 100 milliliters. So for the second step, let's see. We need to see if our volume is ordered in milliliters. Okay, well the volume ordered is 1 fluid ounce. We need to make this into milliliters, and we know that in milliliters is 30 milliliters. Okay, so the second step we had to convert to milliliters, which we've done. Third step, we're going to go ahead and write the fraction with the unknown in the numerator and the total volume of the compound to be prepared in the denominator. Okay, so this is going to be x over 30 milliliters. We'll go ahead and squish the third and fourth step together. We'll set this equal to our proportion piece up there of sodium iodine powder all over 100 ml. Okay, we can go ahead and cancel out the milliliters right now, and then we can go ahead and cross multiply. We're left with 100 times x equals 30 times 5 grams of sodium iodine powder. And then we can divide by 100. So 30 times 5 is going to be 150. Dividing that by the 100, we'll get 1.5 grams of sodium iodine powder. Okay, so applying the rule we had for preparing a solution, thus a recipe for preparing the solution would look something like this. 5% iodine, sodium iodine, it will have sodium iodine, 1.5 grams, and water, however much we need to create 30 milliliters. Alright, so next procedure checklist 19.2. Calculating quantities for percent strength liquid compound by the proportion method using ratios. Okay, so once again, we're going to refer to rules 1 and 2, depending on if we have a solid or a liquid medication we're using. We'll set up a ratio. We'll make sure to convert any volume to milliliters. After that, we'll write the ratio and solve. So for example 5, we're told to calculate the amount of pure ethanol needed to prepare 400 milliliters of a 20% ethanol solution using water as a solvent. Okay, so what are we given? Well, we're given a liquid medication. So for this first step, since we're given a liquid medication, we're going to go ahead and write this out using Rule 19.2, which is 20 milliliters pure ethanol to 100 milliliters. Once again, we're using ratio method, which is why we're using the colon. So the second step, let's see, is this expressed in milliliters? Yes, it is, so we don't need to convert. We already have the milliliters. Third and fourth step, once again, I'm going to combine them. First, we're going to start out with the ratio that we know, which is we have X to 400 milliliters. Okay, then we'll go ahead and set up our two ratios in the proportion method and add in that double colon there. That is going to be equal to the 20 ml. Oh, sorry, this was supposed to be 20 up there. That was a typo. 20 milliliters pure ethanol. And that's to the 100 ml. Okay, so we can go ahead and cancel the milliliters. We'll solve for the unknown by multiplying out our means and extremes. Okay, so our means are the 400 and the 20 ml pure ethanol. Okay, so let's see, writing that out, we get 400 times the 20 ml pure ethanol. And then we'll go ahead and multiply the extremes. Setting this equal to X times 100. Alright, let me go ahead and write this out again. So 400 times 200 is going to be 8,000 milliliters of pure ethanol equal to 100x. Then we can solve for x by dividing both sides by 100. And we have 80 milliliters pure ethanol equal to x. So writing the recipe as usual using Rule 19.3. Here's going to be our little recipe for 20% ethanol solution. Should be a capital E actually. Okay. For pure ethanol, we're going to use 80 milliliters. And for water, using as much as needed, 400 milliliters. Alright. Next we have Procedure Checklist 19.3. So once again, we're going to refer to Checklist 19.1 and, Rules 19.1 and 19.2 to determine if we're working with a liquid or a solid. And then we're going to write the fraction from the percent strength desired with the amount of medication in grams or milliliters in the numerator and 100 milliliters in the denominator. Once again, we'll convert the volume to milliliters. And then for 3, we'll write an equation with the unknown x on one side, and then write the volume ordered in milliliters multiplied by the fraction from step 1 on the other side. So once again, we are using dimensional analysis to solve. Last step, cancel units and solve for the unknown. So we're given calculate the amount of pure ethanol needed to prepare a 250 milliliter of a 70% ethanol solution using water as the solvent. Okay, so our first step, we're going to apply either Rule 19.1 or 19.2. Well, we are given a 70% ethanol solution, which is liquid. So we're going to go ahead and use Rule 19.2 and write it as a fraction, 70 milliliters pure ethanol all over 100 milliliters. Then the second step, we're going to go ahead and see if the volume ordered is in milliliters, which it already is. We have the 250 already in milliliters, so no need to convert. Third step. Okay, we'll go ahead, writing the equation down with x on one side, equal to the volume that we have ordered, which is 250 milliliters, times our fraction from step 1. So the 70 milliliters pure ethanol divided by the 100 milliliters. We can go ahead and cancel out the milliliter unit, and we're left with x equals 250 times 70 milliliters pure ethanol all over the 100. Okay, we can cancel out those zeros, and then we're left with 25 times 70, which will give us 175 milliliters of pure ethanol. Okay, in here we had step 4 and 5. And then let's go ahead and apply rule 19.3. We can go ahead and write our recipe for preparing this 70% ethanol solution. So pure ethanol, we have 175 milliliters. And then water, we have however much is needed to get to the 250 milliliters. Okay, so that was it for 19.1. Let's go ahead and move on to 19.2, solid and semi-solid compounds. Alright, so solid and semi-solid mixtures are made up of two main parts, the active ingredient, or the medication, and the base, or the inactive material, into which we have our ingredient measured. So for rule 19.2, for solid or semi-solid, this is actually supposed to be rule 19.4, sorry, please go ahead and edit that. For solid or semi-solid mixtures containing a medication, the percent strength represents the number of grams of a medication contained and 100 grams of the mixture. So for example, 20% zinc oxide, ointment contains 20 grams of zinc oxide in every 100 grams of the ointment. Alright, for our procedure checklist 19.4, this is calculating quantities for percent strength solid or semi-solid compound by the proportion method, and using fractions instead of ratios. So we're going to refer to 19.4, rule 19.4. Then we'll convert the quantity to grams. Step 3, write the fraction with the unknown x in the numerator and the total quantity in grams of the compound to be set up in the denominator. For step 4, we'll set the two fractions up as a proportion and solve as usual. For 7, calculate the amount of base needed for the compound by subtracting the amount of medication needed from the amount of product needed. So example 2. Calculate the amount of hydrocortisone powder and cream base needed to prepare 1 ounce of a 2% hydrocortisone cream. So what does the first step state? Well, we're going to go ahead and apply rule 19.4 to create the first fraction. We have 2% hydrocortisone, which we know we're going to write as 2 grams hydrocortisone powder. All over 100 grams. Okay, and the second step, let's see. We need to make sure that this is in terms of grams. We have an ounce. Okay, so we need to convert that. 1 ounce. Well, we know 1 ounce is the same as 30 grams. Okay, so we did the conversion. Third step, we're going to go ahead and set up the first part of the fraction. We're actually going to mix this step 3 and 4 together. So we have the unknown over the 30 grams. Then we'll go ahead and set that equal to our fraction up there, the 2 grams of hydrocortisone powder, all over the 100 grams. We can go ahead and cancel out the grams now, then cross multiply to solve. We're left with 100x equals 30 times 2, which is 60. 60 grams of hydrocortisone powder. That's a long word, powder. Okay, then we can solve for x by dividing by 100. And we have solved for x, so x equals 0.6 grams of hydrocortisone powder. Oops, let me just write grams for G. Okay. And then let's go ahead and squish the instruction or the recipe for preparing this. Let's just squish it up here. So a 2% hydrocortisone cream. What do we need? Well, we need hydrocortisone powder. I'm just going to go ahead and abbreviate that. Powder. We need 0.6 grams. And then, so to find the cream base, what we need to do for step 7, so let me go ahead and squish this in here, step 7, we're going to go ahead and subtract the amount of hydrocortisone needed from the amount of the product we need. So we know that we need 1 fluid ounce, right? That's what we were trying to find. But we translated 1 fluid ounce into 30 grams. So we need 30 grams, and we're going to subtract away the amount that we're going to be putting in of the hydrocortisone, which is 0.6 grams. Subtracting that away, we end up with 29.4 grams for the cream base. So for the cream base, we'll get 29.4 grams. Okay, so that's one of the main differences here is when you're using the cream base, you gotta subtract away the amount you added there. Different than using water. Alright, so keep in mind what you're mixing with. So procedure checklist 19.6. Calculating quantities for percent strength liquid compound by dimensional analysis. So once again, you're going to refer to rule 19.4 to write your fraction. Then we'll convert the quantity to grams, write an equation with the unknown x on one side, solve using dimensional analysis, and then step 6 to calculate the amount of base needed for the compound. Once again, we'll subtract the amount of medication needed from the amount of product needed. So step 1, referring to rule 19.4, we're going to go ahead and write the 2% as 2 grams of not entirely certain how to say that one, divided by the 100 grams. Try, Miss Sloan? I'll go ahead with that one. Okay. So the second step, the volume that was ordered is 2.5 ounces. Alright, remember we need to convert the quantity ordered to grams. So since we know that 1 ounce, that was an ugly Z, 1 ounce is 30 grams, we can go ahead and find out that 2.5 ounces, multiply that by the conversion factor. We'll go ahead and get 75 grams. Okay, so once again we had to convert to grams. So 2.5 ounces is 75 grams. Okay, so now let's go ahead and set up our equation. Remember, we're using dimensional analysis. So we set x equal to, we'll go ahead and use our 75 grams, multiply that by our conversion factor, or just, our fraction from the top, which which I went ahead and looked it up. It's 2 grams of triamcinolone. Triamcinolone. That is how apparently it is pronounced. Alright, over 100 grams. Okay, we can go ahead and cancel out the grams. Multiplying the 75 times 2, then dividing by 100, we get x equals 1.5 grams of triamcinolone. Triamcinolone. Okay. And then, so lastly, remember when we're filling out our order slip, our recipe, we need to figure out how much of the cream, or the Vaseline in our case, to use, because in this problem, we're using Vaseline. So we need to figure out how much Vaseline to use. Since this is not water, we're going to have to go ahead and subtract the amount of Vaseline. We're subtracting the amount of triamcinolone needed from the amount of the product that we need. Okay, so we know we have the 75 grams, and we're going to subtract from that what we found out we need, which is 1.5 grams, and we'll end up with 73.5 grams, which is the amount of Vaseline we're going to use to in total get the 75 grams. So for our 2% ointment, our recipe has, I'm just going to go ahead and abbreviate that. We got 1.5 grams. And then since we're using Vaseline, remember, which is different than using water, we had to go ahead and do that subtraction. That's the little R trademark. We need 73.5 grams. Okay, so one of the main things to remember is if you're not using water, or if you're using the cream or something, you're going to go ahead and have to do that subtraction. Right there. Okay, so let's go ahead and move on to section 19.3, diluting a stock product. Okay, so a stock product or stock products are commercial products, that you have on hand. So medication orders are sometimes written for a concentration that is not actually commercially available. So when this happens or occurs, you will calculate the quantities needed to prepare a compound of the desired concentration. The procedure used to determine these quantities is known as the alligation method. There are two situations in which it is necessary to use the alligation method. First situation, if you have a stock product with a concentration that is greater than the desired concentration, you need to calculate the amount of stock product and the amount of dilutant to mix. So that would be if you're trying to make less. Second, if you have two stock products and the desired concentration is between the two, you need to calculate the quantities of the two stock products to be mixed. The alligation procedure is the same in either situation. Okay, so let's go ahead and see what actually is the alligation method. So, looking at procedure checklist 19.7, this is for calculating quantities needed by the alligation method. So you write out a tic-tac-toe grid, like on the side here, and fill in the following values. The units of concentration must be the same for all three values. Please note that. You need to have all the same units. But we won't include the units when filling in the grid, because we can assume they're all the same, so we don't really need to worry about including the units. And also note, if you're diluting a single stock product, so just one item, the lower concentration will be 0. Okay, so let me point out the values you're going to fill in. Higher concentration, the desired concentration, and the lower concentration. And once again, if you're only working with one stock product, the lower concentration will just be 0. Okay, so when we're working with this, what you do is you take the diagonal differences. Okay, so take a look at this example here. So take the diagonal differences means you're going to do the higher concentration minus the desired concentration to get this box down here. And then you would do, okay, so please note this is a little bit different. You're going to do the desired minus the lower concentration up to the top. Okay, and then for step 4, you're going to find the size of one part by dividing the total number of parts into the quantity of the product that is needed. Step 5, multiply the side of one part by the number in the right top of the grid. The result is the amount of the more concentrated stock product needed. Okay, so when the product is a liquid, there is no need to calculate the quantity of the less concentrated stock product to use. You add a sufficient quantity to achieve the desired volume, as we did when we were calculating mixtures with water. If the product is a semi-solid, such as a cream and an ointment, you need to do the subtraction of the more concentrated stock product needed from the answer from step 5, from the total amount of the product needed. Okay, so same idea here. If you're using water, you just need to add the amount to achieve the desired volume. If you're not using water, you're going to have to do that subtraction, which we did in the previous sections. Okay, let's take a look at an example. So example 1. Calculate the amount of 90% ethanol in water needed to prepare 500 milliliters of 50% ethanol. Okay, so we're going to have to go ahead and fill out the grid. Let's see though, are we using a single stock or multiple stocks? Well, we're just using a single stock. We have 90% ethanol. Okay, so that's just going to go ahead and be my higher concentration of 90. Since we're only using one stock, that means my lower stock will just be 0. Okay, so now let's go ahead and fill in the desired concentration, which is going to be the 50% ethanol. Okay, so let's go ahead and take the diagonal differences. We're going to have the 90 minus the 50, which is going to be 40. 40 parts needed. And then we're going to go ahead and take the diagonal the other direction. The 50 minus the 0. There's going to be 50 parts needed. Okay. So the part A, let me go ahead and write this out. So we need a total of 50 parts of 90% ethanol. And then the other one, a total of 40 parts of water is needed. Okay, so step 3, the third step we're looking at, is we're going to find the total number of parts I'm going to do this by adding the two values in the right column. Okay, so the right column, adding them up, we have the 50 parts, 90% ethanol, plus 40 parts water. We end up with, let's see, well, 50 plus the 40. We're going to get 90 parts total. Alright, so the third step, we're going to go ahead and find the size of one part. And how we do this is we divide the total number of parts into the quantity of the product size that is needed. Okay, once again, I'm just reading this off of the steps that we have listed above. So to do step 4, what we're going to do is take the total number of parts, and we're going to divide that into the quantity of the product that we need. So what is the quantity of the product that we need? Well, the quantity we need is 500 milliliters. So we're going to go ahead and divide that by the total number of parts, which is 90 parts. And that's going to end up equaling 5.56 milliliters per part. Okay, lastly, fifth step. Actually, there's one more step, but on to the fifth step. We're going to multiply the size of one part, okay, so this one, multiply this by the number in the top right of the grid. Okay, that would be the 50. Okay, so multiplying them together, we get 5.56 milliliters times the 50. That will give me the 278 milliliters of 90% ethanol. Okay. Alright, so let's check the sixth step. Well, what did we use? Did we use a cream or a liquid when we were creating this? Well, we were just using a water, so we don't have to use that subtraction method we did before. We'll just go ahead and use water. So since the product is water, there's no need to calculate how much we need to add. We're just going to dilute 278 milliliters of 90% ethanol with however much water we need. To bring the total volume. Well, how much did we want again? We wanted 500 milliliters, so bring the total volume to 500 milliliters. Okay, and there we go. So, 278 milliliters of the 90% ethanol with just enough water to bring the total volume to 500 milliliters. Okay, so lots of little steps here, but they're pretty well labeled out. Okay, let's take a look at the next example. Okay, example 2. Calculate the amount of 0.1% and 0.5% triamcinolone cream needed to prepare 60 grams of the 0.2% cream. Alright, so first thing I note here is that we're putting this into a cream, so I know we're going to have to do that subtraction later on. We're not just putting it into water. The next thing I notice is we're using two different concentrations. Okay? So we're not just going to use 0 in the bottom. So the higher concentration is the 0.5. The lower concentration is the 0.1. The desired concentration is 0.2. Okay, then we'll go ahead and take those differences like we did before. 0.5 minus 0.2, and we get 0.3 part needed. Then we'll do the other subtraction. We'll get the 0.2 minus 0.1, which is going to be 0.1 part needed. And let's go ahead and follow the steps above. So real quick, part A, we have a total of 0.1 part of 0.5%. I'm going to abbreviate that, cream is needed. And then next we have a total of 0.2 part of the 0.1 cream is needed. Alright, so let's move on to step 3. So to find the total number of parts that we need, we're going to go ahead and add up the parts on the side. So we have 0.1 part plus a 0.3 part. And we end up with how many parts? Well, 0.1 plus 0.3 is going to give me 0.4 parts. Okay, so we found the total number of parts that we're going to be using. Now we need to find the size of one part. And we'll do this by dividing the quantity we want by the total number of parts. So how much do we want? Well, we want 60 grams. So we're going to go ahead and divide the 60 grams by the total number of parts that we have, which is 0.4. Okay. And that is going to be 150 grams per part. Okay, next step, step 5. We're going to go ahead and multiply one size of the part by the number in the top right of the grid, and that is going to be the amount for the more concentrated stock product that we need. Okay, so that would be multiplying that by the value up here. Sorry, that's getting really messy up there. Okay, so let's go ahead and multiply that out. The 150 grams per part, right from right there, multiply that by the part we found on the top, which was the 0.1 up here. And we'll get 15 grams of the 0.5% triamylone cream. Okay, so we found that. And then the step 6, we're going to subtract the amount of the more concentrated stock product, which we got from step 5, from the total amount of product needed. Okay, let's go ahead and do that subtraction. So for step 6, we know we want a total of 60 grams. That's my total. And we'll subtract from it the amount we found from step 5, right here. 15 grams of 0.5% triamylone cream. And that will give me 45 grams for the 0.1%. Okay, so subtracting away the amount of the higher amount, we'll find out how much we need for the lower percent of the cream. All right, moving on to the last section for chapter 19. 19.4, specific gravity. Okay, so specific gravity is the measure of the density of a substance. Okay, it is equal to the mass of the substance divided by the mass of an equal amount of, or an equal volume of water. Since it is determined by dividing one mass by another, specific gravity has no units. That's kind of neat, having a value that doesn't have units. Alright, let's look at rule 19.5. So the volume of water in milliliters is equal to its mass in grams. Alright, so example 4, determine the mass of 150 milliliters of water. Well, we know from the rule that the volume of water in milliliters is equal to its mass in grams, so 150 milliliters of water will just have 150 grams as its mass. Alright, pretty straightforward on that one. So now let's go ahead and work on specific gravity. So, next checklist, 19.8, calculating the specific gravity of a solution. This is a very grave problem. Alright, so first step, convert the mass to grams. Okay, so convert from mass to grams. Then we'll look back at rule 19.5 to write the mass of an equal volume of water in grams. Just this rule right here. Pretty straightforward. Then we'll enter our values that we got from steps 1 and steps 2 into the following equation. Go ahead, cancel units, and solve our equation. Alright, let's go ahead and try this one out. So example 2, calculate the specific gravity of a solution if 30 milliliters of the solution has a mass of 42 grams. Alright, so what is the first step? Well, the first step is to convert the mass to grams. Well, the mass we're already given is actually already in grams, so we don't need to convert that. We're pretty good there. So the second step is write the mass of an equal volume of water in grams. Well, we know that, what are we looking at? We're looking at a solution of 30 milliliters. So, this would then have a mass of 30 grams. Alright, so step 3, we're going to go ahead and fill out our equation. Specific gravity is going to be equal to the mass of the solution, which is going to be the 42, divided by the mass of an equal volume of water. So the mass of an equal volume water, 30 grams. Okay, and once, as we've noticed, the grams will cancel each other out, so we won't actually have a unit. So then 42 divided by 30 will be 1.4. So the solution has a specific gravity of 1.4. And remember, there are no units for this problem. Okay. Let's keep moving. Next, procedure checklist 19.9. So calculating the volume of solution in milliliters from the specific gravity and mass. First step, convert the mass to grams. Okay, as kind of usual there. Then we're going to divide the mass of the solution by the specific gravity to find the volume. Okay, so kind of the opposite of the formula we had previously. Example 3, glycerin has a specific gravity of 1.25. Calculate the volume of 50 grams of glycerin. Alright, well we know, let's see. The mass is already in grams. In the second step, well, using the equation that we know, specific gravity equals mass divided by volume. So specific gravity equals mass divided by volume. And we want to solve for the volume. So I can go ahead and plug mass in, which is 50 grams. My specific gravity that I'm given is 1.25, excuse me. And remember, that doesn't have units. So then we're trying to solve for the volume, so let's go ahead and cross multiply. And we get 50 grams equals the 1.25 times the volume. We'll go ahead and divide both sides by 1.25. And we get that the volume equals the mass divided by the specific gravity, which is 1.25. Okay, hence where we get these directions right there. So what would that be? Well, that is going to be 40. Okay, and what we're told is that the volume of the solution is in terms of milliliters. So we know that this is going to be 40 milliliters. Okay, so my answer is 50 grams of glycerin has a volume of 40 milliliters, period. Okay, let's look at the next example. So a 10% solution of acetic acid has a specific gravity of 1.014. Calculate the volume of 1 kilogram of 10% acid. So the first step we have to make sure, is this in grams? Let's see. Well, we're given 0.1. Sorry, 1 kilogram. We're given 1 kilogram, which is not in terms of grams. So we're going to have to go ahead and convert that to grams, which is going to be 1,000 grams. So that's my mass. Next, we need to figure out what the specific gravity is. And we are given that, which is specific gravity 1.014. So we can go ahead and we know that the formula is the volume is going to be the mass, which is going to be 1,000, divided by specific gravity, which is 1.014. So notice I went ahead and just did this shortcut for volume. Instead of solving using the long formula, I just solved this way using the long formula to show you where they got their shortcut from. So we're going ahead and working with just the shortcut here of volume equals mass divided by specific gravity. Okay, so then volume equals 1,000 divided by 1.04. That's going to be, let's see, 186.2, which we round to the nearest tenth. So, 1 kilogram of 10% acetic acid has a volume of 986.2, and remember the units we are using is milliliters. Okay, let's see, looks like we just have one page left. So the next thing we're calculating, procedure checklist 1910. Calculate the mass of a solution in grams from specific gravity and volume. So kind of what we're doing for all of these problems in 19.4 is we're using the same equation, specific gravity equal mass divided by volume. We're using the same equation and playing around with it to solve for each of the different units here. So this time what we're doing is we are going to be solving for the mass this time. So the first thing we're going to do, as usual, is convert the volume to milliliters. And second, we're going to multiply the volume of the solution by its specific gravity to find its mass in grams. So what this is saying is multiply the volume by specific gravity to find the mass. Okay. So first step, let's see. Is the volume in milliliters? Well, yeah, it is. We're given 200 milliliters of cod liver oil. So we don't need to convert. It's already given milliliters. So second step, we're going to go ahead and find our mass using the formula. Mass equal to volume, 200 milliliters, times the specific gravity, which is 0.925. So then mass equals 185. All right. So 200 milliliters of cod liver oil has a mass of 185. And remember, actually, mass is supposed to be in terms of grams, so I'm not going to be using these units when I'm multiplying. But for these problems, mass is in terms of grams, volumes in terms of milliliters, and specific gravity, remember, has no units. So mass is in terms of grams. Okay, let's look at the last example. Ethylene glycol has a specific gravity of 1.125. Calculate the mass of a 2-ounce ethylene glycol. Alright, so the first thing we have to do is our mass, is our volume in terms of milliliters. It's not. Right now it's in terms of ounces, so that's a problem. We're going to have to convert the volume to milliliters? Well, 2 ounces, remember 1 ounce. 1 ounce is 30 milliliters. So 2 ounces is going to be 60 milliliters. Alright, so we've converted to milliliters. We can go ahead and solve now. So second step, remember we're using that the mass is equal to the specific gravity times the volume. Okay, so mass is going to equal the specific gravity, which was 1.125, times the volume, which we had was 2 ounces, but we converted to 60 milliliters. And then we have that the mass is going to equal, so 1.125 times 60 is 67.5. And remember, the units for mass is grams. So in my problem, or my answer, 2 ounces of ethylene glycol has a mass of 67.5 grams. Okay, so one thing to remember for these 3 different types of problems, if you're solving for mass, specific gravity, or volume, the main thing to remember is the main formula, which is specific gravity is equal to the mass divided by the volume. If you remember that formula, you can go ahead and play with it to find the answers for either specific gravity, mass, or the volume.